All right, so we just have to get through this back side here. So here's some rules for you. If A is an invertible matrix, so basically when something's invertible, that means you are able to find the inverse of it, right? So if something is invertible, then the inverse of the inverse turns back into the original. So that's just like a little fact, okay? If both A and B are square matrices, and they're also invertible, then the multiplication of the two will also be invertible. So you can multiply them and then do the inverse. And the inverse of AB, so the inverse of AB, the multiplication of the two, is the same as if you did the inverse of each one and multiplied them in reverse order. So this is kind of like the transverse rule that you saw earlier a little bit. And again, you know, these little rules, like, it's just if you needed to switch it around. Like you could just do this or you could do that. You don't really have to remember that they're the same, but helpful sometimes. All right, and then part C. If you have an invertible matrix, then the transpose is also invertible. And the inverse of the transpose is the transpose of the inverse. All right, so the inverse of the transpose is the transpose of the inverse. So if you needed to use that. All right, so let's go ahead and work through these little pieces here. So first of all, in letter A, I need the inverse of matrix A. So let's go ahead and do that. So the determinant will be 3 minus negative 1. So that'd be 4. So I have 1/4. And remember, I have to switch them around. So I switch these two, make these ones opposite, like negative 1 and positive 1. So my inverse right there is 1/4, 1/4, and negative 1/4 and 3/4, multiplying that. All right, so that's the inverse of A. And over here, remember, when I multiply something by its inverse, it makes the identity matrix. Like this equals the identity matrix. So that becomes 1, 0, 0, 1. All right, so my answer to that is 1 and 1/4, so 5/4, negative 1/4, positive 1/4, and 3/4 and 1 is 1 3/4 or 7/4. All right, so BC. So we could do that if we wanted to. So if we need to, we will. But let's look at this. So let's use some of our rules right here. So inverse C times inverse B, I'm going to use this rule right here. This is simply, if I switch it around, this is simply turns into that. So it's going to be BC, because they're going to switch places, and inverse, right? And so that is what the inside turns back into. Well, it still has an inverse out there. Well, if I do the inverse of the inverse, it basically cancels itself out. So this all just pops out to BC. So I end up with BC minus BC, and if you subtract something from itself, you get the 0 matrix. So they're all 2 by 2s, so we'll put 0, 0, 0, 0. Or you can just put 0, but you know. All right, and the last one here, the transpose of B times C. So why don't we just go ahead and do B times C, and we'll transpose it when we're done. So B times C. So probably this was meant to be easier if I had actually done it there, but whatever. So I could do 1, 2 times 1, 2. So I get 1 and 4. So 1 plus 4 is 5. I do 1, 2 times negative 1, 0. So I get 1 times negative 1 and then plus nothing. Then 4, 3 times 1, 2. So I get 4 and 6, so 10. And then for the last one, 4, 3 times negative 4, 1, or 0. So I get negative 4. All right, so when I transpose this, remember the rows become the columns. Rows become the columns. And that is it. All right, this last little bit right here. Let's see, another way that we can find the inverse. So remember on our warm-up, on that little paper that I had you do, we did some steps to a matrix, and we turned it into the identity matrix. We put it in reduced row echelon form. And then we copied those steps on the other side onto the identity matrix. So that's kind of inconvenient to do it separately. So what you can do is you can do the steps. You can kind of put this dotted line and do the steps to the matrices at the same time. So let's do that here. So we're going to put them together, and any step that I choose to do here, it'll get done to this as well. So I think the first step that I choose is this, or actually the only step that I choose. This one's so basic. Or there's actually a couple steps. So I'm going to get rid of this -1 by adding these together. So I'm going to take row 1 and add it to row 2. So that's going to be the 1 and the 4 will stay. The 1 and the 0 will stay. But my new second row is 1 plus -1, 4 plus -3, and 1 plus 0, 0 plus 1, 1. So now I will do, to get rid of this guy right here, I will do -4 times row 2 and add it to row 1. So let's see, the bottom is not changing. Ah, crud. Sorry. 0, 1, 1, 1. Let's see, -4 times row 2. So -4 times 0 is 0. Add it to 1. -4 times 1 is -4. -4 plus 4 is 0. That's what I wanted. I get here -4 plus 1, so I get -3. And here I get -4 plus 0, so I get -4. And so what that does for you is it will produce the inverse over on the right side. So this right here is a -1. Okay, so it produces that for you there. But again, you know, you could have done the whole determinant thing. That was just to kind of get you used to it, because we're going to do it with a 3x3 matrix here. All right, so this is our last problem. I have 2, 0, 0. I got -3, 0, 1, 0, 1, 0. I'm going to put my identity matrix for a 3x3 here so that I can keep track of the steps and do them all together at once. All right, so I think I'm going to do 1/2 row row 1 to get rid of that 2 right there. And I am also going to swap row 2 and row 3, because you see how this is a good second row for my identity matrix. All right, so remember, we're trying to turn this into the identity matrix. All right, so this becomes 1, 0, 0. I'm multiplying by 1/2, so I get 1/2, 0, 0. I'm going to write this in the second row, 0, 1, 0, 0, 0, 1. I'm going to write this in the third row, -3, 0, 1, and 0, 1, 0. Okay, one small step, I need to get rid of that -3. Oops, sorry, I don't pay attention to what I'm seeing on the screen. So I have to multiply 3 times row 1 and add it to row 3, and we'll be done, because that'll get rid of this for me. So everything else is staying the same. And 3 times row 1 added to this makes 0. 3 times nothing plus nothing is still nothing. 3 times nothing plus 1 is still 1. 3 times 1/2 plus nothing is 3/2. 3 times 0 plus 1 is still 1. 3 times nothing plus nothing is still nothing. So this guy right here is the inverse of the original. So it's helpful if you want to find the inverse by hand of a 3x3. Of course, you could also put in your calculator and put the little -1 on it. But if you multiply this matrix with that matrix right there, if you multiply those together, you will get the identity matrix right here. And that is it. I'll see you in class. Make sure you do section 2.1 problems for homework.